Welcome to microwave engineering, and here I'm going to discuss about this microwave transmission line. This is the continuous lectures of previous video. So here I'm going to discuss about the coaxial transmission line and the microstrip transmission lines. This is the coaxial transmission line, and here you can observe this coaxial transmission line is this is a conductor, that is pin, which is shielded by this dielectric that we called as an insulator. This we called as an insulator, and this is an outer covering for this insulator, which it avoids any interference or this thing. So this inner conductor, and here this conductor, you can see this a cross sectional diagram, and here this is a inner conductor D is an inner conductor, that is of conductor, and here this D2, that is we can see this is a cross section of outer shielding, that is of D2. So now what I do is this D will consider for our explanation. Will how we can take this we can say as a radius, that is of small d of this conductor, and this d2 is nothing but capital, that is of distance of this cross conductor. And here if you see this conductor, so here if this is an positively charged, so how this current will be there, that is electric field. This current will be in the out of focus direction, that is out of focus phase. So this current which is following out of phase to this outer conductor. So how this magnetic field will be there according to this term rule? If we are facing this pin in this direction, so this opposite plane, this if this is an electric field applying this plane surfaces in the electric field direction, this phase, that is of vertical phase, this opposite will be the magnetic field, that is applying the thumb rule condition. And here you can see this magnetic field. So this magnetic field is flowing opposite to this electric field. So this we can say as an engine, this general funda, like this electric field and magnetic field are opposite to this phase. So if we are applying this electric field in this direction, that is of out of phase, so the current magnetic field be in this horizontal phase. So here you can see this circularly it is inside this conductor. And how this inductance and capacitance is calculated with this formula. This formula is similar to this transmission, and here there is one slight change. This is how we are using this changing only in this parameter. This of L, inductance L is equal to mu naught by 2 pi ln of d by d. So the d is the distance this is distance of this outer conductor, and small this is of inner conductor, this is of pin, radius of this pin, and capacitance is this 2 pi epsilon divided by ln of d by d, capital D by small d. So d is the distance of the outer conductor, and this outer surface area d, and small d is an interconductor region. And here this as already I have discussed in the previous lecture, this circuit diagram will be the distributed circuit will be the same for this coaxial two-wire transmission. This will be carried out till the microstrip transmission line based on how we are placing this component. And so here this characteristic impedance is Z0 depends upon this inductance and capacitance, that is of nothing but Z0 is equal to root of R plus J omega L divided by G plus J omega Z. So in two-wire transmission line, this is a lossless transmission line, so that's why we have they will have the minimum amount of resistance and conductance, so that we have been neglected. But here this is a lossy transmission line cable, coaxial cable, so we'll consider this R plus J omega L divided by G plus J omega 6. So next we'll see about this microstrip transmission line. A strip type transmission line, we have the two types. One is we can say of microstrip line, microstrip transmission line, and strip based transmission line. So this is nothing but the strip based we can say as in coplanar transmission line. So here, this in microstrip transmission line, we have the transmission line is placed on the dielectric material, and this reference plane. This we can say as an ground plane. So this ground plane and in top plane, that is of transmission conducting plane, which is separated by the dielectric material, and this conductor is placed on the dielectric material and microstrip line. So this we can say this type of transmission we use for this designing an antenna purpose. For an antenna similar to this, we'll have the ground plane, dielectric material, and then top we'll have the top conductor. This we call as a top conducting surface layer. And this is a strip line transmission line model. And in strip line transmission line model, we have suspended the transmission line inside the dielectric material. That is, we have the which is so we have this two reference plane. So we call it as two conducting surfaces. We can see as in ground surface, and this will be a top surface. This is also will be the reference plane, and here we are suspending the transmission line inside this dielectric material. This is we call a strip line transmission line. And in if you see in designing of purpose of antenna, we called as a suspending of hoop and transmission line. This placing and slot inside between this two between this top patch antenna and this ground wheel suspended a micro strip between this. So for that purpose we use this transmission strip based transmission line. And thanks for watching.